Let us go back again to the beginning. We recall that we did this bench side and the whole bench idea last week, even though we didn't do the thing as complicated as this, but at least you have enough information to go and spend your time and do as accurate and as good a drawing. And you have to go and take your own measurements. Don't worry about my measurements. If you don't like my measurements, don't ask me any questions about my measurements. Take your own tape, your own ruler, your own vernier caliper, digital one, or all the other equipment for measuring. Go there with your recording paper, with your camera, take all your photographs you have, and go and do your own bench based on any bench that you see on campus or anywhere else for that matter. Then you can form components. Your components may not be exactly the same. Form components like this, and let us have them. Put reinforcements in them. Later on, we will analyze that with reinforcements. This another one is this connecting rod that I did with 7 circles. This is 1, 2, 3, 4, 5, 6. Where is the 7th circle now? This is 1, 2, 3, 4, 5, 6, 7. Yes, 7 circles. And then we do extrusion to get this. And then we said there are practical issues we will still look at on this thing. Then we now talk about a piston. Later on, we talk about the crankshaft. And then this is the dimensions that I am starting with. And as a result of this dimension, we can draw 4 or 5 horizontal lines. We draw a line at the top here, this horizontal line here, draw another horizontal line at the bottom here. We draw a 3rd horizontal line to coincide with the level of this end here. We draw another horizontal line here. We draw the last horizontal line here because we know all these distances. Then after that, we draw the first vertical line, that's vertical line 1. Then we draw the vertical line 2, and we draw vertical line 3. So there will be 3 vertical lines and 5 horizontal lines, and we dimension them. Somebody just came and said, why did you get these lines? I don't know where he was sleeping or whether he came late to class. So we did that already. And then we showed how to, one way of doing the connecting the piston rings, one way to put them is to use rectangles. And then after you've done one rectangle, you can now copy and paste those rectangles, making sure that the create copy check mark is switched on there. So that is one way. There are other ways. You can just do 1, 2, 3 lines, and that's it. That can be fast. So it depends on what you are used to. So because of that, when we started with these lines, we can turn all of them to construction lines by marking them as a group and pressing X. We turn all of them to construction lines. And then if you want to turn things back from construction lines, mark the thing and press X again, it toggles. Then we said, if you are going to create a solid, the first thing you must ensure is that you have a closed circuit. If you don't rush, make sure your circuit is closed. Otherwise, you are going to have a lot of pain. Just save yourself from the pain by making sure you have a closed circuit before you try to do any solid. Revolve is a solid creation thing. Extrusion is another solid. Lofting is another one. There are other ways you can get. Sweep is still another one. There are several ways you can create solids. Sir, can I draw my sketch first before adding dimension? Yes, you can draw your sketch first before adding dimension. Just that those lines will not be fixed until you add the dimensions. Just try things out. Not only, there are several methods that you can use that will work. So you use whatever is more convenient for you. The thing about Fusion 360 is that modeling in Fusion 360 is that it gives you all sorts of opportunities. So, sorry, please just give me a minute. sorry, had a small domestic challenge, which I have attended to. Okay, so that is the fact that you must be sure that whether you are sweeping or revolving or extruding or lofting or whatever solid you are creating, you need a closed circuit. So many times your errors are coming from lack of closure in your circuit. So several options in creating this. The present strategy is by no means the only way to do this. Master it, then proceed to look for alternative ways that you may prefer. Consider 2-point rectangles and so on. I did all this. Then you could see other ways to make sure this circuit, at the end of the day, there must still be a closed circuit. Once you have the circuit complete, the signal of light blue color appears again. It doesn't miss it. Once it knows that your circuit is closed, it will tell you because it's very important. You can see that in this case now, I have put a spline here to create some headroom here that could be used. And then you can finish your sketch by clicking End Sketch. Then to revolve, you select Create Revolve. You can create your own revolve axis so that a coordinate axis is needed. So in this particular case, you can make sure that if the revolve axis does not coincide with any coordinate, create a line on your own, but be accurate. Your revolve axis must be perfectly accurate. If it is not accurate, it may mean that part of the solid cut into the other, and it will not compute. Fusion 360 will refuse to revolve the thing for you just because of that. So make sure you have a perfect closure, and you have a perfect right angle. If it's to be vertical, it must be perfectly vertical. If it touches an edge, it must touch the edge. It must not cut it. It must be tangent. And it must not, no matter how slightly it cuts it, it's going to give you problem. You just see that your revolving is not agreeing to do, and then you don't know why it is behaving that way. It behaves in very funny ways. So after you have done your revolve, you can do an inspection. You can do a section analysis. Take a section and cut through. I will do. Let us go to Fusion 360 and take a look at that. See this one. The first thing is here. Let us go back today. So you see, we have 1, 2, 3. We have three coordinate planes. We don't need to even use those coordinate planes, but for now, let us just use those coordinate planes. We will later create other planes. You can do your section analysis to any plane you like. For instance, suppose I'm interested in doing a section analysis to the ZX plane. So I take this plane, and I go now that I want to do inspect. I want to do section analysis. Under inspect, you see section analysis. So I can move this plane now. I can move this plane as a cutting plane through. If I'm too fast, let me slow down so that you can see it. I hope everybody can see this plane I have taken out of the ZX plane. Can this plane be seen? The plane I am on now that is showing yellowish, okay? Yes, so with this arrow, I can cut through the element with the plane. So you can see it is cutting through, it's taking sections, and it's letting you see the section through what you have created. So it takes that section, this is about halfway, and then it now reduces again. It reduces again until it gets out on the other side. So that is the section, that is the section analysis. Okay, so cancel that. You can create another section through the XY. So you say inspect section analysis. So you can go down. You see it is taking section. It's slicing. So slices, expands, contracts, expands, contracts, expands, now contracts gently until it gets. So that is the section through that. So you can take any plane. And right now we are using the coordinate planes. You will see later on, we are going to take planes that are not coordinate planes. And you can see the small space we created on top of the piston using the spline that we did before. So when we did it with the solid of revolution, you can see that. So this is our simple dashboard. For instance, there may be corrections to be done. Maybe the positions we have allowed for the piston rings are too fat, and therefore they are occupying too much space. So we may have to reduce. We may have to thin them down. You will start do that later on, and we will do that later on. But these are things. Let's see. Is there, do you have any questions for me at this point before I go to the next thing? Because the next thing, we have not finished with the piston yet. We are going to now show how to attach the connecting rod to it. Any questions for now on how we did this? Let's see. Nothing in my chat. You are all happy with this? Okay, good. So let me go further on my slides. So this is no longer strange to you. You can see that I'm doing a section analysis, and this is the ZX plane I'm using here, and I'm cutting through. So many people that want to do AutoCAD, everything you do in AutoCAD, out of the 6 workspaces in Fusion 360, most of what people do in AutoCAD is just one of the workspaces, and you can get all the results. There is nothing you can achieve with AutoCAD that you cannot achieve in a much neater and easier way here. So that is the reason why we go into this effort to do solid modeling instead. And this is easier. We actually teach this at secondary school level. So I don't see why it would be thought that this may be hard for undergraduates. No, it's not. So we can now, I want to now show that we can edit the sketch. One power of a timeline-based modeling package is the ability to modify it on the timeline. So what I'm saying is this. Remember how before we did the revolve, remember how we created this profile. You know, we created this profile by dimensioning these distances. We can go and change. If we now go back to the sketch and we change these distances and we say, okay, it's going to reflect back. Let us go and do that, and you see what will happen. Let's go back to Fusion 360. And here, I'm going to do an edit. Because what I'm going to do is that this distance here is 3.8. I want it to be 3 instead of 3.8. Then this one is 2.5. I want it to be 1.5. And this distance, I want this distance here, from here to here is 5. Let me try and see whether I can change that distance. I can just create a dimension here, and I take this and this, which is right now 5.8. I want to turn it to 3 or 3.5. Oh, okay. So then I want this, let me make this big. I want this distance instead of 2.5 to be 1.5. So you can see that maybe you can see that these distances have become very, very, very much smaller. If I say, okay, I don't know whether you notice that it has now reflected in the sketch. In fact, I can make another one here and remove the one here. So let me just go and remove the last one. And I want to remove the last notch for this and put it somewhere up. So let me go and edit that again. Edit sketch. And what I'm going to do is that I'm going to copy this. And say modify copy. Oh, no. Undo. So modify sketch. edit sketch. Okay, instead of just even wasting my time on that, let me just do a line here. And then do a trim. Then I want to close this one up. And then say finish sketch. Okay, so it did this third one, but it didn't close this up. Let me see why it didn't close it. I go back again to do my edit sketch and see what happened. Edit sketch. Maybe let me see whether I can remove this. Let me trim this off. Okay, end sketch. Okay, so you see. So I can go back to my sketching and do something else, and it will be reflected, since it is whatever sketch it has there that is going to use to do the revolve. So that is the advantage of that timeline. So you can see now I've created the same number of holes, but I've moved them up, and that may be useful for what I'm going to do next. So let's go back again to this, what we did here. What did we do? Let's go back to the, what am I doing here? I'm going to go back to PowerPoint. I'm going to my WhatsApp. Okay, so section analysis. So we are in the section analysis now. So one power of timeline modeling is the ability to modify the timeline. So in modifying the timeline, we went to modify the previous sketch, and then because the revolve took place after the sketch. So that revolve uses the latest editing of the sketch. Use an example to demonstrate. I have to use that example. So the next thing we are going to do now is to see where we are going to put the connecting rod. We have to put a structure inside. If you look at this page, you will see that in this particular piston, you have a structure that has a hole, which through which you can pass a bolt or something that will hold the connecting rod. And we have to create this structure now. That is what we need to do. So we are now, not now. Let me just correct that. We are now so we are now to create the holding structure for the connecting rod inside the piston. This is an example of such a holding structure. See, this is the example of the holding structure. Now, what will we do? How do we do it? Well, the thing is to create, we go to either the ZX or ZY plane on the coordinate plane and create this. You create a rectangle, you create a center rectangle that ends at the lower point, that ends at the lower point of this, what do you call it? That ends at the lower point of the profile for the piston. And then on top of it, you create a circle. So after creating that circle, you trim, so that you have something that is a flat base, two sides are flat, and then the end of it is a circle, a semicircle in this case. So choose the ZX or ZY plane. The choice of the sketch plane is completely arbitrary in the assembly process. I think we have enough time for, instead of talking here, we have enough time. We want to make it 30 by 24. So let us go and do it. And we'll get this thing done so that you can see it in the final design. Okay, so what I'm going to do now, I'm going to go to my AutoCAD and to my Fusion 360, and I'm going to take this plane and say create a sketch. I'm going to create a sketch on this plane. No. I don't want to create a sketch. I can go and edit the original sketch. Edit sketch. Okay. I'm going to edit this sketch. And what I will do in editing the sketch is that I will start by creating from here. I'm going to create from here, from this point, I'm going to create a rectangle, a center rectangle. That center rectangle ends at the beginning point of the, it ends at the beginning point of the beginning line of the underside of that thing that we revolved. So if I am happy with it, the width here is 19. Well, maybe let us make that 25. Let's make the width 25. And then the height. The height, let us make that height 12. Okay. Okay. So what I'm going to do is that since I know this distance, since I know the height of this is 12, its half height is 6. So I'm going to force this one now that the distance between here and here is 6. If I make the distance between this middle point and this top and this edge here to be 6, then I am sure that it will just be exact match. But before I do that, what is even more important? I want to be sure that this line, I want to be sure that this point here and this point here are on a vertical plane. So I'm going to put a horizontal vertical constraint there. So that forces this line, the middle of this rectangle and this edge here to be on the vertical plane. So let me just make it big. So the middle of this rectangle and this point are on a vertical plane. So that assures us that this is on the vertical plane. The next thing, I want this distance from here to here, I want it to be 6 because I know that the half height of the rectangle is 6. So I'm going to create a dimension there. Create a dimension and it is from here, which is fixed, to this one. And I'm going to make that 6. So you can see what has happened now. Because that is 6, that one now meshes with the lower part of this. So the next thing to do, if I make this thing small, the next thing to do is to put a circular, something here, a circular line here. So I will say create circle. I'm going to create a 2-point circle. So this is a circle that starts with this point and ends with this point. So that is a circle that is, that's a circle there. And I will now have to do some trimming. So I'm going to do some trimming. I want to trim this off, trim this off, trim this off. You have to be careful here that you don't trim the wrong thing. If you are not careful, you will trim the wrong thing. And then okay, so you can see what we have here. We are going to create an extrusion of this. When we create an extrusion of this inside the dashboard, and this extrusion is a special extrusion. We are going to learn not extrusion only, but to do extrusion of the profile plane. Ordinarily, your extrusions begin at the profile plane. All your solids begin at the profile plane. But in order to do that, let me first of all say I've finished my sketch. When I now go to the browser. The first thing I go to do in the browser, you'll see that even though the sketch is there, it is turned off. I turned it on. I turned the sketch on. If I turn the sketch on, and I can take a look, I can rotate this thing a little bit so that I can see inside. So you can see where that thing I've just created is. So what I want to do now is that I want to do an extrusion of this. So I want to create an extrusion. I want to create an extrusion of this quantity, this thing. I've selected that. Now, it says start. I don't know whether this can be shown bigger. Start. Normally, when you are extruding, it gives you the profile plane. Now, I want to start at an offset plane. So it now says, what offset? So I want it to be offset by a distance of minus 20, say. Or, okay, it seems as if 20 would be from a distance of 20. Okay. Let me just say minus 20 because it depends on where I am going. So if it's minus 20, and then it says direction one side, distance. Now I'm now going to choose my distance as to object. So I'm going to choose this object, which is the furthest inner surface of the piston. That will be the object to extrude to. So, and it's asking whether it is a cut or new body. So I want it to be a new body. So let us see how it looks like before I accept it. Yes, it is quite okay, but the distance I choose is too much. So let me use a minus 15 instead of minus 20. Minus 15. Is that good? Or minus, let it be minus 12. Or even minus 10. Minus 10 should be okay. Minus 10. So if I'm happy with that, then I choose a new body, okay. So let us go home and go upside down and see this structure inside it. But we want this structure, you can see that, you can see the profile plane here. You can see that we did that, we started the extrusion from an offset plane. Ordinarily, if you didn't do that, then you now have to go and cut. If you are cutting, it's because you do not understand the power of Fusion 360. Fusion 360 does not need you to extrude first, do too much extrusion, and then later go and cut. And I don't need to know the distance. The distance I want is that the thing does not get beyond the inner part of the piston. So what I'm going to do now is to make a mirror of what I have done here on the other side of it. So I can do that by creating a mirror. I create a mirror, and it says type of mirror. It is say faces. No, I want the mirror to be bodies. I want to create a mirror of bodies, and it says select object. So this is the body that I want to mirror, and then it says select mirror plane. My mirror plane is easy to select. My mirror plane here is the YZ axis. So it's the YZ axis, which I choose now. If I choose the YZ axis, you can see it has mirrored it to the other side. If I'm happy with that, I click OK. So you'll see that now I've gotten my mirror, I've gotten the structure. So all I need to do now is to put the hole that will hold the piston inside this place so that we can put the piston there and pass that hole through it, and it will be held at that point. So let us go back again and see what we were trying to do from the slides. Look at what we were trying to do. We wanted to create this structure. The only thing left now is to create this hole. And to create this hole is very easy. In fact, it's so easy that I do not want us to finish the class without creating the hole. You can create this hole. There is a correction we need to do. If you cannot do that correction today, we'll do it next week before we move. I'll give it to you. I will give that correction to you as homework. So what we now need to do is to create this hole. To create this hole is relatively easy. To do that, let us go back again. The best thing for us to do is to go we can create a new sketch, but it's often very easy to use the sketch that is existing. So I prefer to edit the sketch that I have here. I say edit sketch. So when I get to this sketch, what do I want to do? I want to create a hole that is going to hold the connecting rod. And then I can start by creating a circle here. I want to create a circle of a diameter. Let the diameter of that circle be 10.2 or 10.1. Because what I want to put in there would be the internal hole in the connecting rod at that point is 10 millimeters. So let's just use 10.1. Okay, if we do this, we put this here. Let us see what we now do. We can say finish sketch. So we are going to do another extrusion. The extrusion we are going to do now is a cutting extrusion for both sides. Okay, it's a cutting extrusion. And let us see, we create extrude. And then the thing is to select the profile. This is the profile. It is this inner circle. And then we can start from the profile plane where we want a symmetric extrusion. And the extent type now is to object. It's not, the extent is, okay. It's not letting me choose object. Maybe because I used only one. Okay, let me just do it only on one side and see whether, okay, I prefer to use it. I like my extrusions to go to object. The object I want is the outer surface of this thing. And I want it to be a cut. Okay. So let us see now. Let's see what we have done. See? You see, this is the hole. So this is the hole where a bolt will go in and hold the connecting rod inside. Now we have to do the same thing on the other side. It's not easy. To do that, we are going to create a mirror. We're going to create a mirror, and the mirror we want to create this type is faces. It is faces. And we select this face, the face of the bolt inside here. And we have selected that object. We now need to get the mirror plane. To get the mirror plane, we said the mirror plane is, that is the mirror plane, okay. We didn't do it. Okay, let me do it again. Create. It didn't compute, create mirror and faces. Let me be sure that the face is selected to the end. Okay. Okay, so the next thing is the mirror plane. I don't know why I'm not getting the result I want here. So, because I'm not getting the result I want, I use a crude method. I don't have time to check why I'm getting an error there. So what I'm going to do, I'm going to use another method to do this thing. Just extrude it backwards. So I'm going to extrude it. I'm going to create an extrusion. I think I'm now seeing why it's not working. I'm going to create an extrusion. I'll tell you that next lecture, but I think I have an idea. One side again, distance is to object. And okay, the profile to extrude is this one. And is to cut through that object to that side, cut, okay. Okay, so let us see what we have now. So you can see what we have here. So you can see here, we have the hole through which we can put a bolt and then hold the bolt can come in here and hold the connecting rod in place inside this place. So don't forget that I can still go and edit this feature. For instance, if I choose this feature, and I say edit feature, you remember that the offset was -10. If I want it to be tighter, and I want the offset to be -5, I said, okay, everything will be the same. So you can see how it looks now. You can see how it looks. I can turn off the sketch so that it doesn't disturb. So you can see it here. You can see that it's now tighter. I can go back and say, well, maybe 10 is even too small. I want it to be 12. Edit feature. I want the thing to be minus 12. The offset be minus 12. And I say, okay. Okay. So you can see it here. So when you do these things correctly, you are going to have a lot of control over what is happening. Now our time is, we have 1 minute to go. And I want to give you a homework assignment. Your homework assignment is this. Take a look at this. Take a look inside here. You will see that extrusion, some of it is the extrusion of the structure. Some of it came out of the dash of the piston and is disturbing this. It's now disturbing this position that is supposed to be occupied by the piston rings. I will put this. Let me cut this picture and put it in the slides so that you will understand the question I'm giving you. Let me cut this picture and put it in the slide. Let us insert a new slide. So I want you to tell me what's the best way to clean up this error. Because this structure, let me show you the structure. This structure here is disturbing, is interfering with the slots we created for the piston rings. So I want you to tell me, how do you clean that up? How do you correct for that? So when I hear your own answers by next week, that will be where we will start. Our time is up, but before you go, let me remind you what the assignment is. Even though you have a month, and my experience is that students think, oh, it's going to be a month. That's a long time. You have to work the entire month. If you do not work the entire month, you just discover that you do not have enough time to do it. So this is on this page. You have to clean this up. You have to tell me how you will clean it up so that the interference, because you can see this, it is not interfering with the whole hair, but it is interfering with the whole hair, with the notch hair and the notch hair. So those two are interfered with. How do you clean that up so that you can put your piston rings inside those holes also? So let's just see how you will do it. So you can see from what we have in our Autodesk Future 360, you can see how we created that structure inside and how we can now put we just put a bolt here, and then we put the piston and the connecting rod there, and it will be held. And how do we do that? We're going to do that using the assembly process. So it doesn't matter where you have created those, as long as it can be reached, it will just put it with the correct, it will position it correctly. We will show you how the assembly process is so fantastic that it works like magic. So that is the end of today's class. If you have questions, you can send them to our website. I don't think we have been getting questions from the class, but I hope you know what you are doing. I hope you know that the due date of the assignment is the due date of your assignment, as we told you, is what date now? July 30, 2021. Oh, what am I saying? Yes, what are we in now? Yes, July 30. Yes, we're in July. So July 30, 2021. That is when this assignment is due. But I don't mean that you should start working on it on July 29. Start working on it now, because this has a lot. There are lots of things. You are going to do your connecting rod. You are going to do your piston. You are also going to do your crankshaft. which I will give you an example next week. You can go ahead and do your crankshaft without me. I will just give you an example, but you can do it any way you like. So you can go and read about it. Maybe you have enough information now. You do the crankshaft and then we put everything together. We put bolts and we create we create 3 or 4 components that we are going to assemble together, and then we are going to animate them. So 4:33, 3 minutes into your time. Have a nice day, everybody. Goodbye.